Hello everyone. In this video we will continue to examine topic 5.4, magnetic effects of electric currents, and in particular we will discuss the magnetic flux density. Alright, so at this point we need to return to a topic we'd left a while ago and deal with an annoying and confusing technical point. We have been referring to B as the magnetic field. Strictly speaking, this is ambiguous and we should not have been doing this. Why? Because the term magnetic field is ambiguous between the vector field B, which we've already discussed, and a vector field called H, where H is defined to account for the magnetic response from actual materials. That is, when magnetic fields penetrate actual materials, those materials themselves respond and produce their own magnetization. And so sometimes we're interested in the B field itself, but sometimes what we're actually interested in is sort of the net field. Okay? And you don't need to know about H, but that's why we're actually going to avoid the term magnetic field in our formal discussion. Okay? And it's why our loose definition of magnetic field was given earlier. So what should we call B? B is strictly speaking called the magnetic flux density. Now, I will say, I and everybody else I know are going to call B the magnetic field if it's not ambiguous. But if you're asked to give a definition of B or to give a definition of the magnetic flux density, then the definition you give is defined using our magnetic force law. So the magnetic flux density is formally defined as the magnetic force per unit current per unit meter. And you can formally define the magnetic flux density simply with reference to this equation and label the terms. The unit of the magnetic flux density, B, is the Tesla, where 1 Tesla is a Newton per ampere per meter. Okay, and so there's a sense in which we are defining B using our magnetic force law, just as we defined our electric field and our gravitational field using Coulomb's law and Newton's universal law of gravitation. Now, the fact that it's called the magnetic flux density doesn't show up in very many circumstances, but if you are asked for what the name of this thing is, you need to know that term. What is flux density exactly? Well, that opens a particular can of worms that I will answer here in a second. Know that in higher level topic 11, we will introduce a formal quantity called magnetic flux, given this symbol, defined to be the dot product of the flux density with the area. So you can think of B as sort of the flux per unit area or flux density. But again, this refers to a quantity we haven't seen yet, which is why this name is a little bit strange. You don't need to know any of this, it's worth noting, but you do need to know that it's called the magnetic flux density and that the formal definition of the magnetic flux density is simply with reference to the magnetic force as shown here. Even more technically, if you want to go up a level, the B field is defined from the full Lorentz force law. So the B field is simply defined with reference to both the electric force and the magnetic force. And we'll see this a little bit later. So big picture, what do you need to know? You need to know the formal definition of this magnetic flux density here as what we've been calling our B field or magnetic field.